Welcome students. In the last video we will discuss about the phase diagram of the sulfur system, and in that case we will cover all the points related to the phase diagram of the sulfur systems. So dear students, today I am going to discuss the next example of one component systems, and we have to cover the phase diagram of the one component system, and the example is one component system is what? Carbon dioxide systems. Dear students, as we know, these carbon dioxide molecules is at the room temperature, exist in a gaseous state, but when I changing the temperature and pressure of the system, what will happen? This carbon dioxide molecule also exist in the solid state. That means when I change the temperature and pressure of the systems, what will happen? The gaseous molecule, that means the carbon dioxide molecules, also exist in the solid state, also exist in a liquid state, and they also exist in a gaseous state. Okay, so what when this solid form is exist? When I changing the temperature and pressure of the systems, the carbon dioxide is also exist in the liquid form when I changing the temperature and pressures. So all these things, when the solid form is when the solid carbon dioxide molecule are exist in the systems, when this liquid form carbon dioxide molecule is exist in the systems, these three things, these things, equilibrium things, we have to cover when these things happens or in the systems, or on the basis of this phase diagram we can say this is the at this temperature and at this pressure, at the specific temperature and at this specific pressures, the solid form is exist, this liquid form is exist, and at the specific conditions this carbon dioxide molecules get converted into gaseous state. So what from this phase diagram we can say at this point temperature is here and pressure is here, so what will happen? The equilibrium between the solid and gaseous states. If suppose I want only solid state, I want only solid what? Carbon dioxide molecules, what I want to change? I want to do constant temperature, I wanted to keep the temperature constant and increasing the pressure. At that point only what? Solid carbon dioxide molecule exist. When I maintaining the temperature of the systems and increasing the pressure of the systems, what will happen? At these points, the collections of these points, if I collect the sample from these points, what will get? Only solid components of carbon dioxide molecules are exist. So this information comes from what? Phase diagram. This information, that means the at what point the solid exists, of carbon dioxide molecules are exist in the solid form, at what point the what carbon dioxide molecules are exist in the liquid state, and at what point the carbon dioxide molecules exist in the gaseous state. This informations will get from what? Phase diagram. So let us discuss the all these things. So what will happen when I change the temperature and pressure of the what? Systems, that is carbon dioxide systems. So this is the phase diagram of carbon dioxide systems, and as we know, these carbon dioxides are exist in the solid, liquid and gaseous states. So this is the triple points. As we know, at the triple point the degree of freedoms are 0. We have to we were in the last video we were calculated, we can say this is the triple point. Triple point indicates by symbol O. At this point the degree of freedom are 0. That means the F is equal to 0. That means this is the non-variant systems. Non-variant systems. If you wanted only this solid, liquid and gaseous state, the carbon dioxide molecules you want to do in this carbon dioxide system, you want solid form, liquid form and gaseous form, then you have to collect the sample from at this point. The temperature and pressure is given here. At this triple point, temperature is what? Minus Temperature is what? Minus 57 degrees Celsius. Temperature is what? Minus 57 degrees Celsius, and pressure is given here. Pressure is what? 5.2. 5.2 atmospheric pressure. This pressure is given here at the point of O. That means the triple points, we can say this is this point from C to O and A to O and B to O. These points meet at the point O, and so we can say these are the what with the temperature. What is the temperature at that point? Minus 57 degrees Celsius, and pressure is 5.2 atmospheric pressures. At this point, what will happen? The carbon dioxide molecule exists in the liquid state, solid state and gaseous state. That means we have to write like that. At this point, what will happen? This carbon dioxide molecule exists in a solid, is equilibrium with what? Liquid form, and is in equilibrium with gaseous form. Okay, so this is the point. Suppose I want the carbon dioxide molecules in 3 different phases in the beakers. So which sample I will collect? At what point sample I will collect? At these points. That means at 57 degrees Celsius, minus 57 degrees Celsius temperature and 5.2 atmospheric pressure of the systems, sample I will collect in the beaker. And after the collections of the this sample molecules, what will happen in the what is the present in the this beaker? What will in the beaker? The carbon dioxide molecules in the 3 different phases. Somewhat amount liquid is there, somewhat amount solid is there, and somewhat amount of vapors or gaseous state carbon dioxide molecules are also exist in the beaker. When I collect the sample from this point, so this is the what? The equilibrium between solid, liquid and gaseous state. Okay, so why I am saying this is non-variant and F is equal to 0? Because at this point, when I calculate the degree of freedom by using phase rule is very important for the phase diagram. So you have to remember this equation, F is equal to C minus P plus 2. This is the phase rules equations. So this is the C is what? Component, number of components, and this already we have indicated that this is the carbon dioxide systems are one component system. So this is 1. Number of phases are what? I mean, how many phases are at the point of O? 3 phases. That's why I am writing like that. 3 plus 2. F is equal to, then F is equal to 0. That means this pressure, the F is equal to 0. That means this is the non-variant systems. Non-variant system means what? You don't vary of the system. You don't vary of the system's temperature. You don't vary. You have to at this point, if you vary the temperature, what will happen? Solid and liquid gets converted. This gaseous form of the carbon dioxide molecules get converted into liquid form. If you vary the just a minute. Okay, if you vary the temperature in keeping constant pressures, if you vary the temperature, if I maintaining the pressure, this pressure is constant of the system. This suppose like that. This is the beaker. In this beaker, I have selected the sample molecules from the point O, and at this point, carbon dioxide molecules are exist in a solid form also, in also liquid form also, and also in a vapor form also. That means 3 different phases are exist in these beakers. When I collect the sample from the O, that means the triple points, when I collect the sample from these triple points, what will happen? The carbon dioxide molecule exists in the 3 different phases. When suppose this is the pistons, and the piston is here and I am heating the beaker. That means this is the burner. Sorry for the drawing is not well, that's why this is the burner. Consider it, this is the burner. Okay, so when I increasing the temperature and maintain the pressure of the systems are constant, that means I am not changing the pressure of the systems. What will happens, I am increasing the temperature when I increasing temperature up to this point, that means I will write like that 25 degrees Celsius. Just imagine part, just imaginary part. When I increasing temperature up to 25 degrees Celsius, so the temperature is increasing but pressure is constant. I am not increasing the pressures of the beakers. So what will happens, increasing the temperature, keeping constant pressures, what will happens, the carbon dioxide molecules from the point O are all the sample molecules get converted into what, gaseous form, because I am increasing the temperature. Okay, this type of process or this type of information get from this is the theoretically informations, and practically what will happen, same thing happens and systems when I keeping the constant pressures and increasing the temperature of the systems. So up to this pressure is constant, but what will happen, change in temperature is increasing here. So increasing temperature, this up to this I am increasing temperature up to 25 degrees Celsius. What will happen, this solid, liquid and of carbon dioxide molecules, solid and liquid carbon dioxide molecules get converted into gaseous state. If I want only solid molecules, if the system is carbon dioxide, system is in front of me, and in the beaker there are 3 phases carbon dioxide molecules exist in the beakers. I want only solid molecules, So what I will change, and after that changes, I want only solid carbon dioxide molecules. So from the phase diagram, I want only solid carbon dioxide molecules. So if I want only solid carbon dioxide molecules, so I will maintain the constant temperature. Of the system and increasing the pressure of the system. So what will happen, only solid carbon dioxide molecules. Up to this I will increase the pressure up to this point. What will happen, keeping constant temperature is constant in the of the system, but I am increasing the pressure. So what will happen, this all the solid, liquid and gaseous molecules gets converted only in the solid form. No liquid is there, no gaseous carbon dioxide molecule in the beaker when I increasing the pressure, and this information gets from phase diagram, and this is theoretical information. When we are doing practically in the laboratory, what will happen, same thing happens in the laboratory when we are doing practical of the carbon dioxide system. So what will happen, like that. Okay, so which states I require of these given systems. I want solid only, then I will change pressure, I will change only pressure. When I want gases only, then I will change in the temperature only. Pressure is constant. We wanted to, if I wanted to gaseous carbon dioxide molecules, and when it exists, when the temperature is increasing by keeping constant. When I want a liquid only, when I want carbon dioxide molecule in the liquid form only, so what will happen, I will change the temperature and pressure also. This is the triple point. After triple points, I will change the temperature, and after that, this is the point, and at this points I will collect the sample from these points, and at this point what will happen, only liquid carbon dioxide molecules exist in the beakers. somewhat amount, minus 50 degrees Celsius temperature at the minus 57 degrees Celsius and at pressure 5.2 atmospheric pressures, what will happen? Triple point, that means solid, liquid and gaseous carbon dioxide molecules are exist, but I want only liquid states, so I will change the temperature and pressure. When I increase the temperature and pressure of the systems, what will happen? The solid and gaseous carbon dioxide molecules gets converted into liquid only. So this informations will get from what? Phase diagram of the carbon dioxide systems. Okay, so at the triple point, F is equal to 0, that means this is the non-variant systems, and temperature is at that point, how many temperature is there? Minus 57 degrees Celsius, and pressure is there at that point 5.2 atmospheric, and at this point the equilibrium is between solid, liquid and gaseous. Three different stages, phases of the systems are in equilibrium form, and F is equal to 0, that means this is the non-variant systems. You can say this at the point of O, the systems are non-variant. Okay, now the next topic, next curve, we have to cover all the curves related to what? I'm just a minute. Minus 25 degrees Celsius, minus 57 degrees Celsius. This point is O. Okay, up to this. So point number second, the point O to A, curve O to A. This curve O to A, at this curve, what will happen? This solid liquid carbon dioxide molecule is in equilibrium with what? Gaseous carbon dioxide molecule. That means which equilibrium is exist at that point, at this curve? Liquid is in equilibrium with gases. This curve is also known as a boiling point curve. Boiling point curve, or this curve is also known as a vapor pressure curve. We can say this is a vapor pressure curve. Why vapor pressure curve or why boiling point? Because liquid get converted into gaseous state, then we can say this is the boiling point of that liquid. Okay, so this curve is also known as a boiling point curve. At this curve, what will happen? Next point is what? We can say like that. This next point is what? At this point, degree of freedom F is equal to C minus P plus 2. Number of component is 1. Number of phases are 2 plus 2. So F is equal to how many? F is equal to how many? This is the minus 1 minus 2. What will happen? 1 minus 2 minus 1 minus 1 plus 2. What will get? Answer first. That means 1. So we can say this is the monovariant systems. Monovariant curve. We can say this is the monovariant curve. At these points, or we can say the curve O to A are monovariant curve, and we can say this is also known as a boiling point curve or vapor pressure curve. And why monovariant curve? Because from the phase rules we have calculated the degree of freedom of the systems. What will happen? F is equal to 1, and by using this F is equal to 1 or by using these phase rules, we can say this is the monovariant system. This is the monovariant systems or monovariant curve. Now next curve is what? O to C. Next curve O to C. At this curve, which equilibriums are exist? Solid is in liquid. Solid and liquid. Carbon dioxide molecule is in equilibrium with carbon dioxide is in liquid state, and when solid gets converted into liquid, we can say that point is known as a melting point. So this curve is known as melting point curve. This point is also known as a melting point curve, and at this melting point curve, what will happen? F is equal to C minus P plus 2. Number of component is one component system, and P is equal number of phases is at this curve is 2, so plus 2. So what will happen? F is equal to 1. That means this is also monovariant curve. This is also monovariant curve. This information you have to write in your answer sheet. If suppose questions may ask, like they give the phase diagram of carbon dioxide system, then this information curve O2C what will indicate. So this is the melting point curve, this is the boiling point curve, this is the sublimation curve. Okay, now the next curve. Next curve is what? O2B. At these curves, which equilibriums are exist? Solid and gases. That means solid of carbon dioxide molecules is in equilibrium with carbon dioxide molecule is in gaseous form. Okay, so at these points, this curve is also known as a sublimation curve. Why sublimation curve? As we know, the sublimation process is what? When the solids are directly gets converted into gaseous state, that process is known as a sublimation process. So this solid is directly gets converted into gaseous states. We have gaseous state. That's why we are saying this is the sublimation curve. At this sublimation curve, what will happen? F is equal to degree of freedom, number of component, number of phases plus 2. So number of component is 1 because this carbon dioxide is one component systems, and number of phases are also 2 at this curve, and we can calculate by using phase rule. F is equal to 1. That's why we can say this is the also monovariant curve. Okay, so this is the simple things. This curve O2C, O2A and O2B, all these three curves are monovariant curve. This is boiling point curve, this is melting point curve, and this is sublimation curve, and this is sublimation curve. Okay, and after that you have to write something about the point O, that means the triple point, and at this triple points three different phases are exist is in equilibrium form. So we can say at this point the systems are what? The systems are non-variant system. That means you cannot change the temperature, you cannot change the pressure if you want the solid, liquid and gaseous carbon dioxide molecules in your beaker or in your experimental glassware. So if you are performing the experiments of the carbon dioxide systems, if you want to carbon dioxide molecule in solid, liquid and gaseous state, then you have to collect the sample from this point, and at this point temperature is minus 57 degrees Celsius and pressure is 5.2 atmospheric pressure, and at these points there's what the carbon dioxide molecules exist in the solid, liquid and gaseous state, and if you want these three states carbon dioxide molecules, then you have to collect the sample from this point. And this is the non-variant system. Why non-variant system? Because if you want these three states, if you change the temperature and pressure from these points, you will get only 2 phases. You will get only 2 phases or 1 phases of the carbon dioxide, or one. If you change the temperature, what will happen? Only gases state carbon dioxide molecules are exist in the beaker. If you change the pressure, only solid carbon dioxide molecules are exist. If you change the temperature and pressure, both the temperature and pressures you are increasing, what will happen? Only liquid carbon dioxide molecules are exist. So this is the non-variant systems. This is the non-variant point. If you change the temperature and pressure, you will get only 2 or more 1 phases of the carbon dioxide molecules. Okay, so this is the phase diagram of the carbon dioxide systems, and this is the one component systems. I have covered all the things related to the phase diagrams. If you have any query related to the phase diagram or phase equilibrium concepts, you can contact me, and up to this your syllabus of the chapter number 1st, that is the phase equilibrium, is covered up to these things, and I have covered all the things. If because of this online medium I have missed, I can miss some things. If suppose you wanted to know all the things, or you wanted to you have any query related to the phase equilibriums, so you can contact me. Thank you very much.